Hey, how are you all? I hope you all are doing well, right? My name is Shubham. I am the Chief Operation Officer here at MEMONEET, right? So I guess you all are enjoying well and the preparation is just going awesome. But most important question, I guess it will be in your mind that why I am here with you all today. So, bhai, problem was that I was getting a lot of messages in my DM on WhatsApp as well as Telegram, or whenever I was posting something on my Telegram, I was getting only one message. Sir, I'm getting a lot of issues in physics. Sir, I'm not able to solve numericals. Please help me. So I thought that yeah, I should come forward and try to help you all. Right. So that's why whenever whenever I'm going to get the time, I will record the lecture. I will keep this lecture session always. Means it will go smoothly. Okay. Its time is right now 2 a.m. when I am recording this lecture for you all only because you all I get to know that I have a lot of works, right? Being a CEO, will have to do each and everything, right? But main priority is that if I am able to help you, then I will try my best. Okay. So in this lecture session, what I will do, I will try to cover each and every concept, right? And we will start with first electromagnetic induction, which is basically the BPT 11 syllabus also, right? And yeah, in this lecture, the special thing is that I will try to tell you each and every concept with the help of numericals. Try. Why numericals I have chosen? Because I feel that you all face difficulty in numericals. So if I will try to explain each and everything with the help of numericals, then it will be very easy for you to understand the concept and apply the same concept while solving the numericals, right? So please don't worry. I guaranteed that each and everything I will try my best to cover it, right? Especially in this lecture first. Okay. So meanwhile, I will just request you two important things. That is first thing, if you have any doubt during watching this lecture, please, it's a request. Please go and comment there in the comment box, right? That yeah, I have this issue and how to resolve this issue, right? I will come forward in the very next lecture, right? And first I will cover all your doubts, right? And then I will move for next lecture. Second thing is that if you are the BTS user or Elite user beta, then we have already the WhatsApp support group. Please go in WhatsApp support group, tag me there. I will respond for your all doubts. Okay, I think that is clear for you all, right? But apart from it, I will also give one important thing, that is few questions at the end of the lecture, which you guys will have to solve. For BTS user and Elite user, you all get it in your where BTS support group or WhatsApp support group of BTS or and Elite. I will also try to give for my free users in the Sha Sir free batch. Okay. So without delaying, let's start our lectures. And please, as I am recording this at 2 a.m., so I would request you also, please, just go and single comment, right? Okay, guys. Without delaying, let's start the. See, you all know that what you know. You all know that in the previous lecture we have already covered the magnetic effect of current chapter, right? In that chapter, what you learn, what was the output of that particular chapter beta? Output was that, what output? Output was that whenever, sorry, output was that moving charges is going to produce what? Magnetic field. What? Moving charges is going to produce what? Magnetic field beta, right? So the moving charge is going to produce magnetic field. Then at the same moment, our scientists were excited, especially Neem watch, Faraday and Sir Henry. Both of them started doing the experiment that whether its reverse is also possible or not. Whether its reverse is also possible or not. Then he found that in their experiment that yeah, it is possible. Right? So what was reverse? That if moving charges is producing magnetic field, then moving magnets would produce electric current. Yeah, it is possible. Right? So this was the complete experiment output. But right now we will not focus over experiment. We will try to cover experiment in the next lecture, right? Here we will just go through the output and we will try to understand the concept, right? See, especially here, understand two things. What I wanted to tell you, right? The two thing is that, see, if we have a magnetic field, I guess we have already idea about magnetic field in the previous lecture, right? If we have a magnetic field, understand one thing. But I'm trying to say you, if we have a magnetic field, understand it. We have a magnetic field. See. We have a magnetic field right here. Uniform magnetic field. I'm telling about a uniform magnetic field B, which is everywhere same. Uniform means for here understanding purpose, I'm saying it is same everywhere. Understand it in this region. Okay, I have taken this region. Understand it. This is the region in which uniform magnetic field is staying, and its value is same everywhere, right? Now, in this uniform magnetic field, what I did, I tried to put a coil. Understand it? What I did, I tried to put a coil here. Now, I am moving this coil inside this field only. Where? Inside this field boundary only I am moving. Okay, understand anything? This coil is moving only inside the boundary region of this magnetic field, and everywhere value of magnetic field is same. So my first question is that whether the EMF will be induced in these coils or not. The answer will be no. Why? Because for inducing the EMF, the value of magnetic field linked with that particular coil should change. But here, as we all know that at all the places inside this box, blue color box, the value of magnetic field is same. So if coil is moving here and there inside this, then it is not going to impact, because the value of magnetic field linked with this particular coil will remain same. Means whatever the value of magnetic field will be inside this particular coil, for understanding purpose, I can say inside this particular green color coil will remain same. Why I am saying this? Because beta G, here if coil is moving here, everywhere inside this boundary line, the blue color, the value of magnetic field is same. So it doesn't matter where it is. The value of magnetic field linked with the particular coil is going to be same. That's why no induced EMF will be there in the first case. Understand this point, what I am trying to say. EMF will be induced only when the value of magnetic field linked with the particular coil is going to change. Now, it's not about only its value. When I'm saying about its value, it doesn't mean that it's only value. It's orientation. For example, if right now magnetic field is, understand one thing. Right now the magnetic field is what? Just inside, completely inside the plane of the paper, or the plane of this board, plane of this tab screen, your phone screen. Understand it. Inside, completely inside. Right now I changed its orientation. Magnetic field, I made it little bit tilted. Understand? This is now the direction of magnetic field. P. So now what will happen? Coil will remain in its same position. But now what is happening here? The value of magnetic field linked with the coil is going to change. Why? Because see, understand, right? Initially, in the initial case, all the magnetic field lines were just inside it. Understand it? The wire directly going inside it. This from everywhere. But when I change its orientation, then the value of magnetic field lines, you can understand for more better clearance, magnetic field lines is going to be changed inside this coil, green color coil. So what can we say that value of magnetic field is changing. That's why EMF is going to be induced. You got it. This is the way how we can induce the EMF here. How? By changing the orientation of the magnetic field. Hope you got it. Second thing is that by changing what? By changing the value of magnetic field B. Yeah. Assume that initially we have magnetic field B, right? Now we reduce its value by B dash everywhere. Then magnetic field link with this particular coil will change. EMF will be induced. And understand one thing. Till the time value is changing only for that particular instant, the EMF will be induced in this particular coil. EMF will be induced in these particular coils. Just explaining it again to you that for the time period, the value of the magnetic field linked with this particular green color coil will be changed. Only for that particular instant, EMF is going to be induced in these coils. Okay. And if this coils is having any output device, then or the circuit is closed, then sure electric current will flow along these coils. For that instant only, for that particular instant only it will flow. Better that you will have to keep it in your mind, right? Hope you got it, this much. So this is the first thing which I wanted to tell you. Second thing is about that what? For example, now see, there are multiple cases. This coil by moving came here. In this instant also, the value of magnetic field linked with the coil is changed. Why? Because see, this portion is inside. So here magnetic field is good. But here it is outside. magnetic field link with the coil is now going to change. So tell that if it is coming outside also of this, then also what? EMF will be induced. Hope you got it. But see, understand one thing. EMF is fine. But now see, there are other cases, right? It is moving now like this upward. This. From this position now it is moving like upward directly. So do you feel that EMF will be induced? I guess no. Why? Because right now the magnetic field link with the coil is now again same. The value of magnetic field is सेम. मेरी कहने का सेंस ये है बेटा कि अगर मैं इसको जिस पोजीशन पे अभी ये रखा है, ये वाला पोजीशन, इस पोजीशन में अगर इसको ऊपर सीधे भी ले जाऊं, राइट, सो स्टिल द वैल्यू ऑफ मैग्नेटिक फील्ड रिमेन्स सेम. टोटल मैग्नेटिक फील्ड लिंक विद दिस स्क्वायर will same. Why? Because see, value is same here. This side is free. But see, if this square I am trying to move outside, understand this. I am trying to move outside. Now the value of magnetic field will change. Why? Because now see, this portion will decrease and this portion will increase. So value of total magnetic field link with this particular coil is going to change. So now EMF will be induced. So for inducing the EMF, what will have to be the condition? The value of magnetic field link with that particular coil should what beta? It should change. Okay, that I wanted to tell you with the help of these things. Hope you got it. If still any doubt, please don't forget to pin in the comment, and please ignore these writings. Why I am saying? Because see beta, I am using pen tab, so hope you can understand that right now, right? And now most important thing after this, we'll start with that is magnetic flux. Okay, but that is very important to understand for you all. So please understand it very seriously. What is magnetic flux? Okay, this was the basics thing which I wanted to tell you about the induced EMF and what are the conditions when EMF will be induced. The second important topic is about magnetic flux. For magnetic flux, I will tell you two things. The first thing is about theoretical purpose, means what it actually means in theory, right? What it actually means in theory. So here it is clearly written for you all that magnetic flux is what? Just counting a magnetic field line passing through a given area. Means through a given area, how many magnetic field lines is passing, that to counting is nothing, that is called magnetic flux. This is for only what beta? Theoretical purpose. Understand? This is for what beta? Theoretical purpose. Hope you got it right. For mathematical purpose, which is very important for you all to understand, because we will solve maximum numericals, right, on this mathematical purpose only. So that is very important. And see, understand one thing, these mathematical terms has just came from few experiments. So these are all just experimental data or experimental data basis formulas. So please try to little bit remember it. Okay. So first we will start with very basic things. I told you about theory that in flux in theoretical purpose, what we say, counting a magnetic field line passing through a given area. Hope you got it. Means how many magnetic field lines is passing through a given area, that is called nothing. Its total counting is what called magnetic flux. For theoretical purpose to understand it, but in math, but we know that practically it is not possible to count the magnetic flux. So magnetic field lines. That's why we have a formula to find it out. And before going to that formula, we should have an idea that what magnetic flux is represented by what? Phi. But it is represented by beta. It is represented by the term phi. Here I am trying to write it here also, the phi. This is what? Phi. Okay. I hope you all know about phi. Na? Don't worry for it, my writing. Okay. So it was being found that, what it was being found, understand. See, if we have a magnetic field here, P, the magnetic field P here, right? Don't ignore the drawing, okay? Because my drawing is not too good here on this screen, I guess. Please ignore it. I'm just trying to say that we have a uniform magnetic field B along horizontal direction, okay? Along horizontal direction B, okay? And now we have a coil. Understand one thing. Now we have a coil here, which is placed like this only along this. Its area of cross section is A. Understand? It is placed like this. How it is being placed over a coil? Don't be confused. It is placed like this only. Hope you got it. It is placed like this. This coil is placed like this way. Okay. Now this is called area vector of the coil. Understand one thing. It is called area vector. Hope you got it. If you are not getting it, wait. I am trying to explain you here also. Wait. See, This is called area vector. Hope you got it right. This is what? This is called area vector. But understand, this is area vector. This is area vector. You got it. This pen is showing the, this is the coil, how it is placed, right? And this is what the pen is showing, the area vector. Area vector is nothing but perpendicular to the normal, outward normal. Okay, this is called area vector. Hope you got it right. So this is the way here. Wait. The screen, I got the screen. Yeah, right. This is the coil which is placed like this. Now we have area vector here, area vector A here. Okay, beta, you got it. So in the first case, B is also along horizontal, area vector is also along horizontal. So angle between B and A is what? In the first case, if I am going writing here, first case, B and A, angle is what? 0 degree. First case, right? Ignore writing, I am again requesting, but please. And in the second case, but I am going to tell you one thing. In this second case, that second case is what? See. Okay. Second case is that if this coil is placed like this, understand one thing, this coil is placed like this. This coil is placed like this, then what will happen? Then again, see, the second case is about how it is coil, how coil is being placed. Understand it here from here. This coil is now placed like this, this like this. Now area vector will be what? Out, upward direction. We got it. This is area vector. It clear for you, I guess. This pen is area vector, and now coil is placed like this. Okay, so area vector is now what? Vertical direction, and magnetic field is still horizontal direction. The angle is what? 90 degree. Hope you got it right. Area vector is what? Again, I'm going to explain area vector. Or area vector is what? Nothing but normal to the plane. Okay, which is what? Outside. Now see here. This normal to the plane, perpendicular normal to the plane outside. Okay, so this is area vector in the second case. Area vector is this, and electric field is this. Sorry, not electric, magnetic field is this. The angle is what? 90 degree in the second case. Hope you got it right. So beta, in the second case, angle is what? 90 degree. Angle between magnetic field and area vector A. Now third case is that is something unique. But I will have to use the different color so that you guys will understand it more better, right? I'm using a red color. Right. See it here. Now in third case, what is happened? This coil is placed like this. This coil is being placed like this. So area will be what? Now this like this area vector. I'm explaining you, don't worry for it. How it is like this. See. Now this coil is placed like this. For example, see, this is my coil right now, right? So this coil is now placed like this, understand? And this is magnetic field. Sorry. So this will be what? Its area vector. Or this will be the area vector also. You got it? Clear? This coil is placed like this. Or we can understand that this coil is placed like this. This is for more better understanding, I guess. This coil is placed like this. This will be more clear for you. Understand this. Coil is placed like this. My hand is a coil, right? So it is placed like this. Got it? Like this. So now area vector will be like this. This is the area vector. Perpendicular normal to this position. Now see, understand. This is horizontal line where magnetic field is, and this is area vector. So angle will be something like between 0 to 90 degree. So that I am assuming that this angle is theta degree. Hope you got it right. Don't be confused, but I am trying my best to explain you all. So third case, what beta? In third case, wait. What is happening with this? Wait, it's not right. Wait, I just removed. Wait, sorry. So in third case, beta what? Theta degree, the angle. Hope you got it. So this angle is nothing but what? This angle, this angle. It's what? Theta degree. Theta is what? Angle between B means horizontal direction now here, which is because it is B in horizontal direction. A is what? Area vector. Got it? So I just wanted to tell you in brief here that phi, that is called magnetic flux, in mathematical terms, which we will use everywhere to calculate the values and solve the numerical. This phi is given, is given by, how it has been given by here, I'm writing right. This phi is given by nothing but P dot A. It is just the experimental formula which I'm explaining here. Okay. So don't try to go and try to learn about its proof. It is not required. But phi is called magnetic flux. Is given by nothing but what? B vector and E vector. Okay, if you got it this much, right? And B dot A, dot means it's a dot product. So when we open a dot product, what we get, as you all know, B A cos theta, where theta is what? Angle between B and A. If you got it, this theta is what? Angle between B and A. So in the first case was what? The first case was that when our coil was placed like, we can say in the vertical direction, like this only, right? Coil was like this, and magnetic field was like this. So my normal direction, and also in coil direction, angle was what? Angle was 0 degree. Angle was beta, what angle it was? Angle was beta 0 degree, right? Angle was 0 degree. So in the first case, theta will be what? 0 degree. So value will come what? So value will come our BA, right? In the second case, theta was 90 degree. Hope you got it. That I have already explained theta, how theta was 90 degree, right? So value will come our what? 0 degree, because 90 is what? 0 degree. You all know. So second case will be value 0 degree, and third case is on nothing but BA cos theta. Hope you got it this much, right? But still better, you have any doubt in these concept, please, it's humble request, explain, sorry, just comment box, in the comment box, go in the comment box and tell me, right, how you got this, right? Just clear, I get. But in the comment box, just tell me how you got this. Or if you did not get it, just write whatever you wanted to write, just go in the comment box and write it there. Okay, I will recover it. Hope you got this much what I wanted to tell you here. This is clear, I guess. So now I will move with the next important thing, that is about its unit. So in unit thing, you will not have to do much more, right? Here is written unit of magnetic flux is Weber. Its SI unit is basically Weber beta, and it is also equal to, as we all know that, see, we all just understand now what we got, that phi is equal to BA. Sorry, BA, right? Phi what? BA. BA cos theta means if theta is 0 degree, then I can consider, I am just considering BA case, okay? Because theta is, we already know that it has no unit, right? So B is what? Magnetic flux, sorry, magnetic field. So its value is what? Tesla. So its unit is Tesla, and A is area, so its unit is what? Meter square. That's why phi is unit is also Tesla meter square, which is written here, Tesla meter square. Hope you got this much, right? No doubt here, right, beta? If still any doubt, please tell me in the comment box. I am trying my best to tell you all, right? If still I am skipping something or not able to explain you, then please tell me in the doubt box, right? In the comment box. Hope you got this. Tesla meter square. This is also equal to what? 1 Weber. 1 Weber, which is basically nothing but just a unit of magnetic flux. Okay. Hope you got it. 1 Weber, right? 1 Weber. And also in CGS, sometimes it is not till asked anywhere, but sometimes it can be asked. So you can just remember that in CGS, it is what? Gauss centimeter square and Maxwell. And you can remember one thing which you like don't need to go for its proof. It is not required, right? But 1 Weber is nothing but is equal to 10 to the power 8 Maxwell. Where Maxwell is what? The CGS unit of magnetic flux. Okay, CGS unit of magnetic flux. Similarly, Gauss centimeter square is also the CGS unit of magnetic flux. Third important thing is that it is scalar quantity. Or better, it is scalar quantity. How? Because it is the dot product of two vector quantity, and we all know that dot product of two vector quantity is always scalar, because B is also vector quantity and A is also the vector quantity. It's a dot product, we already just looked over it. So result will be what? Scalar. Because dot product of always, remember it, dot product of two vector quantity is always scalar. So it is a scalar quantity. Its dimensional formula ml square t square e to the power minus 1. How you get it? If you wanted to calculate it, you can get it, right? How? Because you already know that what? Just I got that f is, sorry, phi is equal to BA cos theta doesn't have any dimension, so we will not look over, we will not have to look over it, right? Phi is equal to BA, and we all know that what? F is equal to QVB from previous lecture. What? F is equal to QVB. I'm writing here QVB, right? So from here, B will be what? F upon QV. If you got it, F upon QV. Okay, QV charge. So here we just put this value of B here, but we will get here, see, we will get that F upon QV into A. This is what? Phi. So now here put the value of, you can put the value of, dimension of F, dimension of A, dimension of Q, and dimension of V. V is nothing but it's a velocity. Then you will get the dimension of phi, which is what? Nothing, ml square t square a to the power minus 1. Here A means, don't be confused, A is nothing but it is ampere, which is the dimension of current. Okay. I hope this much is clear for you all. Please don't go with these kind of drawing. Skip this. Please try to listen my words. Okay. Now we'll go with the very important thing. I guess already I have explained you magnetic flux diagram expression of B and A relays, right? I think I already explained you this much. But if you wanted, if any doubt, right, I can explain you these things here also again. That what I told explain you here. Those things I wanted to make it clear again for you all. Those concept which I told you earlier. What concept was that? This is B, which is similar everywhere, right? Magnetic field B, which I just explained is the same thing, right? B. Here again the same thing. Coil is placed. So its normal will be like this. Normal area vector, that is normal, right? So angle in between B and A is what? Theta. So what result we got from here, which you will have to remember here, what? That phi is equal to nothing but what? B dot A, and result is what? B A cos theta. This much you will have to remember better. Phi is equal to B A cos theta or B dot A. B dot A or B A cos theta. This much you will have to remember for today. Okay. This is the very important thing which I have written here for you. Here. So make sure you don't forget it. Okay. I'm trying to highlight it here also better for you. Phi is equal to what? BA cos theta or BA. Please ignore my writing. Okay, beta. Hope this much is clear. So we'll go with next slide. That is very important. This is the first question which I wanted to tell you. See, listen this question, how to solve the question, right? I will tell you. This is the most biggest problem for you all, I guess, right now. So here we'll understand the concept as well as we will solve the question. See, first question, what it is written. A rectangular loop of area this much meter square. What we have? A rectangular loop this much meter square, its area given, and is placed in a magnetic field of 1T. Its magnetic field is also given. With its plane perpendicular to the field direction. With its plane is what? Perpendicular to the field direction. The flux linked with the loop. See, understand this line here. First thing is what given? Rectangular loop we have. Its area given. Is placed in a magnetic field given with its plane perpendicular to the magnetic field direction. So assume, understand this here. Magnetic field is like this, for example. Magnetic field is like this in the horizontal direction. Here written with its plane, means which plane? The rectangular loop plane is perpendicular to the field direction. It means its plane is what? Understand one thing. Plane will be what? This is the plane. This is the complete rectangular. Sorry, if you are not get, I guess it is not clear for you all. Na? Wait, I'm going to make it more clear for you all. Understand one thing from here. I'm trying to make it with different color, right? Then it will be clear for you. See, understand. Whenever we are saying about plane means that rectangular loop, how it is placed. That you will have to keep it in mind, right? I'm trying to change its color, don't worry. That will be very easy for this. I'm going with the blue color, right? See. Understand one thing, how it is being placed here. This is square, okay? This is placed like this. You have confusion, then I'm going to make it clear for you. Don't worry for it. How it is placed actually, right? Hope you got it right, how it is being placed. This is placed like this, okay? This is placed like this, okay? So now it is asking what? It is asking with us the value of magnetic flux links. We have given this B value here. B is 1T, right? Understand one thing. Area we have already given what? 0.1 square meter, right? Square, and we have to find phi here. We have a relation. What a relation we know? That phi is equal to B A cos theta. Where theta is what? Angle between B and D. So now here it is written that with its plane perpendicular to the field, means the plane of this rectangular loop is perpendicular to the field. So now in this case, the field is this, its a plane is this. This is the plane which is perpendicular to the field exactly. Okay, whenever it is saying that a plane is perpendicular to the field, just keep it in mind that the normal of that loop will be what, along the direction of field. Or if you are confused with this, then you can remember like this, that plane is perpendicular to the field means the plane, the rectangular loop, how it will look, it will look perpendicular to the field. So see in this case, see this is the loop, understand, wait, I'm trying to explain you. See this is the loop, it is its plane, this is the plane of the loop, right? It is saying what, perpendicular to the field means, for example, field is, or sorry, field is along horizontal direction, then plane is this, so it is now see perpendicular means 90 degree with this. If you got it right, fine. So in this case, theta is what, 0 degree. How 0 degree? Understand one thing, again the area vector will be what, perpendicular to this, area vector will be what, normal to this plane. So how it will come, understand one thing, this area vector will be like this, A, and B is already in the horizontal direction. So angle between A and B is what, 0 degree. If angle 0 degree, then cos theta is what, cos 0 means 1. So it will come, the value, what it will come, it will come like BA, and we have value of B what, 1 given, A is given 0.1. So answer will be what, 1 into 0.1, that is what, beta 0.1 Weber, 0.1 Weber. If it is not visible here, you can write it here, 0.1 Weber will be the answer, right? Hope you got it this much. If it's not clear, then you can tell me. It is very basic formula, so very basic concept which you'll have to learn it here. I am trying to explain you here once. See here, see this much. See better, like this is what, the plane, this is our rectangular plane, this is magnetic field direction. I have assumed that this is a horizontal direction. Now understand one thing, this is magnetic field direction which is horizontally, like this is horizontal like this, right? Its area vector will be where, sorry, I already told you in initial lecture that area vector is nothing but that the normal to the plane, outward normal. So this is the outward normal, and in this direction only, in the direction outward normal only, the magnetic field is also there. Magnetic field is also there only. So angle between B and A will be now 0 degree. Hope you got this much right. So now phi will be what, B dot A cos theta, instead of BA cos theta will be only BA. Why? Theta is 0 degree, the cos 0 is 1. So now it will be BA. So B is only 1 and A is what, 0.1. 0.1. So value will be 1 into 0.1. What we get? 0.1 Weber. This is your very first and very simple question. I hope you got it. Now we will go with next question. Understand it. In this question, what it is saying, a circular surface of radius 2 meters is placed in uniform magnetic field of intensity 10 T, 10 T means 10 Tesla, in such a way that its plane, understand that, its plane make an angle of 30 degree with field lines. What it is saying, understand this line, it is very important, beta. Its plane, which plane? The circular surface plane, make an angle of 30 degree with the field lines. To understand it, we will draw it here first, okay? What it is saying, we have a circular surface first. Draw circular surface, beta ji. This is your circular surface, okay? Now what it is saying? It is saying that it's a field. Field is what? It's a plane. This is the plane of circular surface. Hope you got it. I guess it is not good now. So I guess we should delete it first. Wait. I'm deleting this concept. So the important thing. See. Understand it here. But it is saying circular surface of radius 2 meter. You have a circular surface 2 meter given, is placed in a uniform magnetic field of intensity this much. Whatever things we have given here, we have given the value of B, that is 10 T. We have given the angle. No, now please don't consider it as a theta right now, till the time you're not able to understand it. We have given radius, so we can calculate area also with the help of radius. Hope you got it, how to calculate it, right? For circular surface, how much area is pi r square? That I think you can calculate from your end, right? Pi r square. In such a way that it is very important to understand. In such a way that its plane make an angle of 30 degree with the field lines. But it is given plane. Plane is making angle of 30 degree. And in between the formula of B dot A, the angle theta is what? Angle between area vector and B, not between the plane and B. Here angle is given what? Angle between plane, the plane make an angle of 30 degree with the field line. The angle is given between what? Plane and B. But we need angle between what? Area vector A means normal to the plane basically, and what? B. What angle we need? Angle between A and B. Here it is given what? Angle between what? Plane and B. So how we will calculate it? See, understand one thing here. What question is saying basically, beta? Here it is saying to us that if this is our circular plane, understand, this is our circular plane. So here it is saying that magnetic field is like this. This is magnetic field, and this angle we have given with 30 degree. We got it because this is the plane. This is the only plane. This is the plane. Got it? The angle between this B and vertical, sorry, not vertical, this plane is what? 30 degree. Got it? But what we need? We need angle between the normal of the plane and B. I mean, normal of the plane will be like this only, horizontal line. Wait, is it not clear? Wait, I'm making it more clear, beta. Don't worry for you all, I am here only. See, this normal will be, but lecture is going to be lengthy for you also. Please don't. This is what? Our area vector. So now we have the angle, but we need this angle. This is basically our theta. Got it? I guess it's clear for you all. So angle is what? 60 degree. How we got? Because we know that this angle is 90 degree total, and here we have given this much is 30 degree. So this remaining will be what? 60 degree. That is what? Theta is 60 degree. This was the concept which was here for you all. Now you can, I get, solve it. If you are not able to solve it, I can write it here. B A cos 60. You can solve it, right? Wait. Is it not going to be more clear for you all? What is happening right now? What? B A cos 60. So value of B we have 10. A you have pi r square. You can calculate it, right, beta? And cos 60 is what? 1 by 2. 1 by 2. You can calculate the value. You will get few values, right? If you are not able to solve it, please you can tell me. Or if you are able to solve it, please tell me the answer in the comment box. If still you have any doubt in this question, please ask with me here, beta. Okay? In the comment box or in the BTS support group or a light group, wherever you are, wherever it is possible for you. So next question we have here, what? The magnetic field B is equal to 2I cap plus 3J cap. A surface of area 1 meter square is placed along XY plane. Find the magnetic flux linked with this area. Understand, this is very important question. Okay, what is saying? The magnetic field B. This is the value of magnetic field given. Now see here, magnetic field is along two axes. Understand it is. Understand better. Magnetic field is along two axes. Where it is I cap. See, I will tell you this question by 2. Okay, the first way. See, it is same magnetic field is along 2I cap plus 3J cap. Means I cap means what? X-axis, and J cap means it is along this unit. And we have area is 1 meter square. It is placed in along XY plane only. Area is also where? Along XY plane only. But we have this area. Understand? This is our area vector. Okay, this is our simple area vector. Now what is it asking with us? It is asking with us that beta, the value of magnetic flux linked with the coil. Okay, so understand first thing, you can solve it two way. How? See, first understand its area vector. Where it will area vector? Its area vector will come outside, perpendicularly outside. Means what? In the Z direction. In the Z direction. Hope you got it. This is X. This is Y. So this is Z direction. The area vector will come in the Z direction. I hope you got it. If still not getting, then try to understand it from here, beta. I'm trying to explain you here. See, this is our XY plane. Hope you got it. This is X. This is our Y plane. This is our Y plane. Okay. Now this is our area vector also. Complete. This is also area. This whole is our area. A magnetic field along this unit and also along this unit. Okay. Understand it one thing. Area vector will come now either perpendicularly outside. Means it will come outward from the screen or toward myself when I am watching this screen, right? Area vector. So now understand one thing better here clearly. Magnetic field is along x-axis, right? And area vector is along z axis. Angle between x and z will be always 90 degree. You got it? And angle between x and z will be 90 degree. So if angle between the area vector and p is 90 degree, then what we get? Magnetic flux 0. You got it? Similarly, for y-axis also understand it. Magnetic field is along y-axis also given. So for y-axis also it is what? Y-axis above, and z-axis is the electric field line. Sorry, the area vector's angle is again 0 degree. Sorry, 90 degree. So again this here what? Magnetic flux will be 0, because we have already learned that pi is equal to p dot a, b a cos 90 it will come, cos 90 0, so pi is 0. In this way also you can understand it. But for more better way, or you wanted to go with numerical way, then you can understand in this way also, which I am going to explain you now for you all. Since I told you that what the area is along xy, so you will have to understand it that's beta, that the area vector will come along z axis. What? It will come along z axis. For example, if area is a, assuming, or 1 unit is given, consider 1 unit, so 1 z means j, k cap, sorry 1 k. You all know that it is what? Dot product b dot a. So p is given, we have what? 2i cap dot, sorry, plus 3j cap, sorry plus 3 is going where it is 3j cap. Keep it this in bracket, go with dot of this a, 1 k cap. You can write k cap only, because 1 k cap is just nothing but it's just a k cap only, right? We know that what? I into k is what? Again, sorry, I dot k, not O, into I dot k is what? 0. We all know that, dot product. Similarly, j dot k is also what? 0. What we'll get? 0 plus 0, and answer will be what? Overall answer will be what? Beta 0 only. Okay, our overall answer will be what? Sorry, 0 only, 0, big bala 0. Okay, but we get answer 0. Hope you got it. If still any doubt, please, it's humble request, comment again. Okay, we'll go with next question, beta, because this lecture is going to be lengthy now, I guess, for you all. A coil of 50 turns at area 10 square centimeter is placed in a field of 0.1 Tesla. The normal to the plane of the coil makes an angle of 60 degree with the magnetic field direction. Magnetic flux linked with the coil. I guess you can solve it. Because this question now is, here it is given what? The normal to the magnetic flux. Normal to the plane of the coil makes an angle of 60 degree. But it is given plane of the coil doesn't make 60 degree, but it is given normal to the plane of coil makes angle of 60 degree, means it is normal to the plane is what? Area vector. Here we have given what? Theta is 60 degree. Hope you got it this point. In the previous question what we did, there what given? That plane makes an angle of 60 degree with the magnetic field direction. But what here given? The normal to the plane. When it is saying normal to the plane, means it is asking about area vector, because area vector is what? Normal to the plane. It means angle between A and B, sorry, area vector and B means magnetic field vector, is given to be 60 degree. That I wanted to tell you in this question. Others is same as you did initially. Apart from it, what is unique here? Number of turns is given. So I think you all know. If you all don't know, then I want to tell you one thing here about data. Sorry, better that if we have one turn, right, the area will, sorry, the magnetic flux will be BA cos theta. If we have n turns, and means any number of turns, then we can multiply this value with n, and BA cos theta. Hope you got this much. No doubt with it, right? Value will be what? And BA cos theta, right? And is what? Number of turns. So here given it is 50. I think all the values are available for you. Area is also, everything is available, right? Just put the value and you will get the answer. If still you have any doubt, please ask with me, right? Next question for you is here, what? A circular disc of radius 2 meter is placed in uniform magnetic field. Makes angle 60 with the axis of disc, the magnetic flux with the disc. This question you will have to solve. This question you will have to solve, guys. This is your homework. Okay, I'm writing it here. This is your what? SW, which you will have to solve and put the answer in the comment box. Or if you are the BTS user or Elite user, please tag me in the group and put this question answer. So this question's answer in the group by tagging me. Okay. And if you have any doubt, you can ask with me also there only. This question number I'm mentioning the SW1. So whenever you are tagging, just put it what? SW1. Okay. You got it? Next question is very important. So we will discuss next question in the next class. So because I think it's a very lengthy lecture for you now. because I want to tell you something more, but we'll discuss in the next lecture, right, guys? Okay. So meanwhile, I will just, I hope that you got everything here. If you have still any doubt, better you can ask with me, right, since it has been already 3 a.m. So for me, right, have to go with more lecture, but I will record other things by tomorrow in the next lecture. Hope you guys enjoyed it. If you have any issues during this lecture apart from the writing things, sorry, please tell me better there only, okay? And yeah, one important thing that please, it's humble request, wherever you feel comfortable that yeah, you feel that this lecture is good, then you can go with this lecture in this way. I will try to explain each and everything for you, all right? Apart from it, better, the most important thing which I wanted to tell you, that is about what doubt thing. Please ask your doubt. It's a humble request. I will tell you each and everything better. Okay. Hope you enjoyed it. All the best. See you in the next lecture. If it's possible, everything will be well. Then I will be in the next lecture for you all. Okay. Till then, bye bye.